What do you do with the slime material? How do you get rid of it?
Yeah, I mean, there'll be a sludge at the bottom of these tanks. And we took samples from that, from a previous batch test, and had it analyzed. And it will have to be disposed of properly, out of the 100-year floodplain, encapsulated, that sort of thing.
All the stuff that's going in the front too?
That'll be sand, and that sand will hopefully have a real good use in the construction industry.
And you test it to see if there's mercury in it? Because there must be mercury in all those samples. Each of the products must have a component.
You know, sand testing that's a good point. We should probably sample that sand and ensure it. Right now, the excavation for sand down in the Sutter bypass, there's also all hydraulic mining debris. I couldn't find any results from that either. So it's kind of like we've been using this hydraulic mining debris in so many different ways from so many different locations. Yeah.
So I want to clarify on the types of samples that you are taking.
Yeah.
Like on head samples, are you taking a water component and a sediment component? And are you doing that throughout the system?
Well, when we did the closed system test, it was a little different. When we sampled this head material, we just took the solids.
Okay, so you are sampling the solids.
Correct.
Throughout.
Correct.
Heads to tails.
Yeah. Yeah. What we have here, this bucket should be all. We should all be interested in what's in this bucket because it's essentially what came off in the accumulator box from the centrifuge. And so we're really lucky to have Will here from Oro Industries to explain how his helical concentrate works, or helical centrate works.
We've got 2 buckets that we concentrates that we took out yesterday and the day before last week. We take I'm going to put this back in there.
All right. Will, you can talk first and show.
Hello, my name is William. I'm with Oro Industries. We actually manufacture and sell gold mining equipment, and we happen to have a multi-helix, reverse multi-helix spiral here. That unit is a very simple unit. It's got 16 continuous leads in the drum, so just like a corkscrew. And the leads actually taper and get larger as they go towards the tailings end. It's also a gravity concentrator, so you tilt it at an angle. The reasoning for the grooves to taper and get larger towards the back is because it separates all your material by size and weight. So it takes all the guesswork out. It will take down your final product to either pure mercury or pure gold, depending on what is in your material. So that machine right there, production-wise, is capable of running up to a half a ton an hour. We won't be doing that on this presentation, but we can process whatever concentrate we have that they're going to produce for me, and we can pull it down to its final stage.
Do you have anything to show us over there? Should we move over there?
So how does that do with black sand?
It actually works really good for black sand. It was actually designed primarily by my grandfather about 35 years ago to handle pure black sand and extracting gold from it. So that was its main purpose at the beginning. So apart from... Yep. I actually had a process over in Calcier Developments where I had 6 units of these, and I was processing over 24 tons a day of black sand, pure black sand. And I was pulling out, and this is all from tailings, of a dredger. So I was able to pull out anywhere from 22 to 24 ounces a month of gold, and so they worked really well. I ran that for 2.5 years.
When we're done here, I invite everybody to kind of take a peek at the port drop there. The green hose drops out the black sand that comes off the magnetic wheel. We've got a pretty good size bucket.
Question on black sand. What portion are you getting of non-magnetic black sand in the process?
Stuff that ends up in the stuff that ends up in the concentrator. Will processes that. When Will processes our concentrate, we're still going to get black sand in that, and that theoretically would be non-magnetic because it's already been through the magnetic wheel. I'm not sure the magnetic wheel is that effective, but assuming that it is very effective, then we have non-magnetic black sand that will be processed with the Oro Industries product. So it's really a finishing product for the concentrate, and when it's got a little power problem right now, but when it's running, we're hoping to be able to really refine it down to a small vial of gold and mercury. A little bit of gold sometimes a little bit more, but the mercury is pretty constant from what we get out of this. Any other questions?
Trace metals in the sediments or in the water, do you see any other trace metals showing up that might be an environmental problem or regulatory problem?
Let Terry speak to that.
We have a suite of constituents we've been monitoring for. Some of them are from the anti-degradation analysis, and some of them are from the 401 permit. We're using all of them right now, but we're still looking at the concentration of arsenic, manganese, mercury, nickel, cyanide, thallium, and selenium in our effluent. The others have been ruled out, and all of these are actually still really low. So we're happy with what we're getting. But we did run an even more full suite early on. Yeah.
What about organic content?
As part of the anti-degradation analysis, we did a bunch of different organic constituents, and they were not a problem, so they were no longer being monitored.
Okay, what, I mean, in process, organic?
Yeah, oh, I'm sorry. Yeah, we actually have a partnership still ongoing with a researcher at USGS, Dr. Charlotte Alpers and Jacob Fleck, that are looking at dissolved organic carbon. And in the process, they're specifically looking at that in the samples. So yes, we are.
What are in the sands, are you testing for strategic also? Strategic minerals that are in this river, or just let them go by?
I have not done a sand sample yet.
We've done a general sediment assay, a full 51 element assay of just the sediment.
The head material that we're putting into the machine, yeah, that was done early on. Like I said, there's no good sample process for that. We tried to do triplicate, replicate tests, and we tried to homogenize. We did try slurry as well as just the material itself to try and get it better. It was very hard to get a good sample.
But you're also doing sediment samples on the tails, so you can compare the head
Correct.
samples to the
Absolutely.
tails.
Yep. Correct. All right, you guys, you've had some of the best questions I've ever heard. You're all engineers. Usually this is not so technical. Oh, yeah.
Is there
I'm not sure what you mean by deposit sample.
composite?
Composite sample, thank you. The operation has only been run in these batch tests. We haven't really run for more than 4 hours at a time. So we don't have a continuous run yet to have that done with. That would continue to test the head material. That would make sense. Tim, I'm going to let you close us off here.
Okay.
One more quick.
You got a quick one?
Yeah, how many hours of operation per day are going to be required in order for this to scale up? Is it going to be running 24 hours a day in order to reach that 200,000 yards or whatever the max?
We plan on running probably from April to November, 5 days a week, 10 to 12 hours, well, up to 12 hours a day. But it'll be a process that we grow into because it's too labor intensive, as you can tell, even with us right now. So the dredge is somewhat remote. It could operate remotely. That's one of the reasons we selected that electric dredge. The other one is it's still going to have to be monitored with the people and equipment that will be running it every day. And then of course we're in the floodplain, so we really need to get all the equipment out of here in the winter time, if we ever do see a normal winter again. But that would be some of our concerns, is to be able to demobilize in the late fall. So that's our plan, and 2 to 3 years out, this material would be removed. But then again, we figured that 10 years from now, we'd have to come back and do it all over again. So it's planned to be a constant process, but not constant operation. And then, as we said, we're really the big goal is to develop something that'll work in Rawlins, because that is a water supply reservoir. Again, Combie is just a diversion dam. The dam is set at a height so that we can get water through into canals to feed western Placer County and western Nevada County with that.
If you had your ideal situation, when would you start working on Rawlins?
We already are, but in a different project. And we're also doing some model pilot programs with that, and we've got an EIR out right now for some sediment removal at Steep Olive Creek, which is the Bear River arm of Rawlins, and then next year we'll have a similar but different project at the Greenhorn Lake. Both different techniques of trying to deal with the sediment and the mercury, and we're just experimenting in many sense.
That's quite exciting.
Yeah, it is, and we are faced with a humongous amount of sedimentation that occurs. The encroachment of that sediment into Rawlins has just been, we've lost acres and acres of recreational land, as well as probably 12,000 acre-feet of storage capacity. With that, I'd like to close and invite you all to come. Carrie and I will stand over by the machine and point to what we've been talking about, but the heart of the machine is the concentrator, so we'll let you look at that. The bucket that I had out here, it dumps the concentrate when we shut down the machine, or if it pickups for any reason, it'll unload the concentrate. So we keep that in a bucket in water, so that mercury needs to be contained in water at all times, otherwise it becomes a vaporous problem. And then when we get this machine running, we're going to run the concentrate and bring that concentrate, which is now about a half a cubic foot, down to a gold pan of material.
Thank you.
Okay, well, thank you.